So the volume, sorry, our video was cut short. The volume of the liquid that will be displaced is equivalent to the volume of the solid that is submerged in that particular liquid. So for the liquid, we had been given the mass and we had been given the density. So you can calculate that volume by simply having the mass that we had been given as 0.05 kilograms. You divide by the density, which is 2000, and then you get that volume as 2.5 times 10 power negative 5 cubic meters. So taking density being equivalent to mass over volume, that is the density now of the liquid, will be given by 0.25 newtons, which is the upthrust. You divide by the volume, which is 2.5 times 10 power negative 3 cubic meters times 10 newtons per kilogram, giving you 1000 kilograms per cubic meter. So we move on. Where is the other question? There was one last question. The last question states, calculate the new balance point of the 50 grams mass. Calculate the new balance point of the 50 grams mass. 40 grams mass remains fixed. That is, 40 grams mass remains fixed, and the 40 grams mass was 20 centimeters from the pivot. So its position doesn't change. If the liquid was replaced with one whose density was 1,500 kilograms per cubic meters, calculate the new balance point of the 50 grams mass if the liquid was replaced with one whose density was 1,500 kilograms per cubic meters. So for this one, for you to be able to calculate that, to get the new balance point of the 50 grams mass, what are we saying? You can first of all find the mass of the liquid that is displaced, and the mass of the liquid that will be displaced will be given by the volume that is displaced times the density. And the volume of the liquid that will be displaced will remain to be the same. Remember, we got the volume of we got the volume as 2.5 times 10 power negative 5 cubic meters, and that was the volume of the solid. So 2.5 times 10 power negative 5 cubic meters, in terms of cubic centimeters, it will give you 25 cubic centimeters. So you take that volume, which is 25 cubic centimeters, then you multiply by its density in terms of grams per cubic centimeters. So you take 25 cubic centimeters times 1.5 grams per cubic centimeter, giving you that 7.5 grams. So that is the mass of the liquid that will be displaced. The weight of the liquid that will be displaced, you simply change that to kilograms and then you multiply by 10, giving you 0.375 newtons. So now, when it is immersed in this different liquid, the upthrust that it will experience will be different. So the upthrust experienced is 0.375 newtons. So the apparent weight, we get it by having the 0.5 newtons, the weight of that solid before it is submerged anywhere, minus 0.375 newtons, giving the apparent weight as 0.125 newtons. So 0.125 newtons is now the apparent weight. When you take 0.125 newtons times the new position of that weight, which is I'm using an x, it should give you 0.4 newtons times 0.20, that is 0.20, sorry, not 0.25 meters. So x will be 0.4 newtons times 0.20 meters divided by 0.125, giving us 0.64 meters. So the new position is 0.64 meters, or simply the 64 centimeters. Thank you. And I'm giving you some work for what the Form 3s did. Kindly check on the wall. Do that work as soon as possible.